So what we've got here, what we're doing today is we're going to identify whether a relationship is proportional using cross product. We're also going to solve for missing values in a proportion. And we're going to solve for a percent proportion by properly labeling the parts and the wholes of a problem. Okay, so it's a lot of I can statements for today. But again, they all relate back to each other very simply. So the first thing that I want to do is go over what a proportional relationship is. You got a preview of it yesterday when we were doing that one problem, that markup problem, where we had the table of information and there was an X in there. And I showed you how to set up a proportion to solve. So you've already seen how to work out a proportion. So this should be pretty quick and easy for you. So here I have an example of two ratios. A ratio is basically a fraction. And when we set those ratios equal to each other, we call it a proportion. So 6 over 8 equals 3 over 4. I want to know whether this is actually a proportional relationship. And the way that I can check if it's actually a proportional relationship is through that cross product. So that means I can multiply my diagonals together. So I would do 6 times 4, and I would do 8 times the 3. Notice that when I'm setting up that diagonal multiplication, kind of looks like a multiplication symbol, doesn't it? Yes. Right? So that should make sense. That keeps in mind, hey, when I want to check for proportionality, I am multiplying. So I'm going to do 6 times the 4, which comes out to 24. And then I'm also going to do 8 times the 3, and that comes out to 24. So what I do happen to have here is a proportional relationship. Now, if I were to go ahead and multiply my diagonals and they were not equal to each other, then that would make it non-proportional. So if we had something like 6 over 9, and I said it's equal to 9 over 15, and I go ahead and do my cross product. So if I multiply 6 times the 15, and I multiply the 9 times the 9, those aren't going to be equal to each other. If I do 6 times 15, I get 90. But if I do 9 times 9, I get 91. Those are not equal to each other. So notice I put an equal sign with a slash through it. That means it's not equal. That makes it non-proportional. So what I want you guys to do right now, you are going to check problems 1 through 4 to see if those are proportional or non-proportional relationships. You're just going to multiply the diagonals and see if they're equal to each other. All right, let's go ahead and check them real quickly. So for problem number 1, guys, as a whole, can you tell me proportional or non-proportional? Non-proportional. Okay, so if we multiply 5 times the 3, what's 5 times 3?
15.
15. And then we're going to multiply 8 times 2, which is what? 16. Okay, so those are not equal to each other, so that makes it non-proportional. Okay, what about problem number 2? Proportional, very good. If we multiply, we're going to do 7 times the 6, which is 42, very good. And then, of course, when we do 3 times the 14, that is also 42. That's why they are considered to be proportional. What about for problem number 3? Good, proportional. Sing it, Josiah. Okay, we've got 6 times that 20, which is 120. Thank you, Adonai. Then we've got that 8 times the 15, also going to come out to 120. So that makes it a proportional relationship. And then the last one, what is that? Non-proportional. Very good. Okay, you guys are doing fine. So if we do 6 times the 16, 6 times that 16, or yeah, 6 times the 16, or 16 times 6, that comes out to 96. And then if you do the 9 times the 11, that comes out to 99. That is not going to be equal to each other, so that's a non-proportional situation. Any questions about how to check whether it's proportional or not? Everybody's pretty easy, simple, right? Okay. So with solving proportions, it's the same setup, but now we're telling you, we're saying, hey, these are proportional relationships, and since they're proportional relationships, I want to know what does the value of my variable have to equal in order to maintain its proportionality. So you're going to do the exact same process, okay? You are going to multiply your diagonals still. So we are still going to multiply 11 times 11. 121. Thank you, Marshall. Okay, and then we're going to multiply t times 100. If I do 100 times a variable, that's just going to come out to 100 and that variable. So we get 100t is equal to 121. And I've now created a one-step equation. What's the inverse operation that I'm going to have to do here, Justin? Division. Good. I'm going to divide both sides by 100. And it's okay if you get a decimal. Perfectly fine to get a decimal answer. You're going to get 1.21 as your answer. Let's do one more together, okay? Okay. So again, all you're doing, girls, I need you two to stop talking to each other. Okay? All you're doing is multiplying your diagonals. It just happens to be that one of those diagonals has a variable inside of it. So it creates an equation that you then have to solve. Okay? So we're going to, again, multiply. This time I'm going to go ahead. I'm going to always keep my orange with the numbers that are diagonal to each other, the two numbers diagonal to each other. And I'll keep my purple with the variable and its diagonal. Okay, so I know I need to do y times 10. What's 10 times y? 10y. 10 times y is just 10y. Okay, what's 5 times 13? What's 5 times 13? 65. Good. So now we've got 10y is equal to 65. What do we do? Divide. We're always going to wind up dividing here at the end. So we do 65 divided by 10. We're going to get 6.5 for our answer. Go ahead and do 3 through 6 on your own. So for problem number 3, we know that we have to multiply our diagonals. I'm going to do 12 times y to get 12y. I'm going to do 9 times the 4 to get 36. And then I'm going to go ahead and divide both sides by the 12, and I'm going to get y is equal to 3. Yes. Okay, so everybody should have gotten y was equal to 3 for problem number 3. Right, let's take a look at number 4. For problem number 4, again, we're going to multiply 7 times k. That's going to give us 7k. We're going to multiply 3 times 4.2. That's going to give us 12.6. And then we're going to divide both sides by the 7. And we'll get that k is equal to 1.8. Good job. Okay, for problem number 5, we're going to multiply the 5 times the w. We get 5w. We're going to multiply that 10 times the 8. That's going to give us 80. And then we divide both sides by 5. Very good, Marshall. Gets you 16. W is equal to 16. Okay, and then we're going to do the last one, number 6. For problem number 6, again, we multiply 0.5 times a. That gives us 0.5a. Then we're going to multiply 0.9 times 10. That gives us 9. And then we'll divide both sides by 0.5. And what do we get? 18. Very good. A is equal to 18. Okay? So that's how solving a proportion works. Yolani and Ashir, I don't know what's going on in your laps, but focus on the board. When you are solving the proportion, you are just creating that one-step equation. You multiply your two diagonals, and eventually you divide by a coefficient. So it's very simple. Multiply, then divide. Okay, let's take a look here at these problems. With these ones, what's going to happen with this is you have to create the proportion. So it's not going to be given to you. You have to actually set it up and create it based off of the information given to you. But it's very simple. A 12-ounce bottle of shampoo lasts Enrique 16 weeks. 12-ounce bottle of shampoo is going to last Enrique 16 weeks. I'm going to go ahead and highlight that information. And I'm going to create a proportion based off of what I see there. It does not matter how I create it. I could put 12 ounces over 16 weeks, or I could put 16 weeks over 12 ounces. It doesn't matter. I'm going to go ahead and just put 12 ounces over 16 weeks, just because I see 12 ounces then 16 weeks. Again, it doesn't matter. If I wanted to, I could put 16 over 12. Notice I'm putting the words with it. There's a reason for that. Because the way that I set this up will determine how I have to set up the second fraction, the second ratio. My second ratio says, how long would you expect an 18-ounce bottle to last him? So in this piece, the only information that they've given to us is 18 ounces. So if I set up another ratio, where do I have to put 18 ounces? Adonai? On top of the fraction, because 12 ounces was on top. Here, I need to make sure I keep ounces on top for the next one. Does that make sense? So again, if I did 16 weeks on top and 12 ounces on the bottom, then I would put that 18 ounce on the bottom. So the ounces matched up with ounces. Okay? But based off of how I have it written, I'm going to put 18 ounces on top. And now, I don't know how many weeks. So what do I put when I don't know a value, Amaya? A variable. So I'm going to go ahead and put X weeks. Now I've got a proportion. And I just need to go ahead and do my cross product to solve. So I'm going to multiply. I'm going to multiply my 16 times my 18. And I'm going to multiply my 12 times my X and create my formula here. Do I need to show you guys that I'm multiplying anymore? Or can I just write 12X is equal to and then what 16 times 18 is? Do I need to show you that I did 16 times 18? Are you guys good? You guys understand that process now? Okay, good. So I'm going to just write that this is 12X is equal to, what was 16 times 18? 288. Very good. So we get, our equation is right here. 2X is equal to 288 based off of us doing our cross product. And now we solve. We just divide both sides by the 12. And we'll get that the shampoo should last 24 weeks. Notice I'm going to put down weeks because that's what the question's asking. Let's take a look at problem number 2 to create our ratios. About 13 out of 20 homes have a personal computer. On a street with 60 homes, how many would you expect to have a personal computer? What two numbers am I going to use to create my first ratio? Ayan? 13 and 20, right? So does it matter if I do 13 over 20 or 20 over 13? No, it doesn't matter. I'm just going to go ahead and just do 13 over the 20. So 13 represents how many homes have a personal computer. 20 represents all the homes, right? So we've got 13, we'll say, computers out of 20 homes. Okay, so now I have to create my second ratio based off of this information. On a street with 60 homes, how many are going to have a computer? So where is the value 60 going to go? Is it going to go on the top or on the bottom? The bottom, right? It's homes, right? 60 homes. Homes was on the bottom, so we're going to put 60 on the bottom as well. 60 homes. And that means that what goes on top is going to be our variable, X. We don't know how many computers out of those 60 homes happen to be there. Okay, so now we're going to go ahead and do our cross product. What two numbers am I going to multiply? Brian? 13 and the 60. We're going to multiply that 13 and the 60. What is 13 times 60 going to give to us, guys? Natalia? Huh? 780. Good. So we're going to get 780 when we multiply the 13 times the 60. And then we're also going to multiply 20 times the x, which gives us 20x. Good. So we'll have 20x is equal to 780. And Guadalupe, what do I need to do in order to get x by itself? What do I need to do to get the x by itself? Same process we've been doing this whole time. Divide. Good. We're going to divide both sides by the 20. Okay, so if we do 780 divided by 20, we're going to get 39. So 39 computers. I want you guys to go ahead and do problem 3, and I think on the second page you can do numbers 4 and 5 as well. Go ahead and do problems 3, 4, and 5. All right, let me go ahead and go over this real quick because I want to be able to get us on to the next stuff. So for here, in a class of 32 students, 8 were absent. So there's the information that I'm going to create my proportion from. So again, I could do 32 students over 8 absent, or I could do 8 absent over 32 students. Doesn't matter. I'm just going to go in the order that I see. 32 students, 8 absent. So based off of that, a school has 720 students. We want to figure out how many would you expect to be absent. So we would have to set it up as 720 students on the top and X absent on the bottom. We could then go ahead and do our cross product. So we're going to multiply 8 times that 72, and that's going to give us 5,760. Then we're going to multiply 32 times the x, and that gives us that 32x. Okay, and then we set it equal to each other. So we'll divide both sides by the 32, and we're going to get that we would expect 180 absent students. Okay, let's go ahead and go to the second page where we have problem number 4. So for problem number 4, it says Josh paid $3.72 for 3 pounds of apples. So again, there's the information that I'm going to go ahead and set it up. I'm going to do $3.72.
Pardon the interruption. May I have Sophia for checkout?
She's on her way.
Thank you.
Okay, $3.72 over 3 pounds. Sophia, it's going to be on, where's Sophia? There you go. It's going to be on Google Classroom today. Okay, $3.72 over 3 pounds. We want to know how much is it going to cost for 7 pounds. So 7 pounds is going to go on the bottom. We have X amount of money on the top. And then we can do our cross product. So we're going to multiply $3.72 by 7. So when we do 3.72 times 7, that's going to come out to 26.04. Then we're going to do 3 times the x. That's going to come out to 3x. And we set them equal to each other. And then we just divide. We divide both sides by 3, and we find out that 7 pounds is going to cost us $8.68. Marshall?
How do you tell the prices on top of one?
So it doesn't matter for the first one. I could do 3 over 3.72, but then that means I'd have to do 7 over x. So notice I always put like a word to go along with it, so that way however I set up my first one will determine how I set up my second one. I want to map the words up together. Do you understand?
Yeah.
Okay. So for like here, it says 93 pages for 62 minutes. So I can do 93 pages over 62 minutes, or I could do 62 minutes over 93 pages. Okay, how do you want to do it, Marshall?
93 over 62.
Okay, so let's do 93 pages over the 62. minutes. So based off of that, here's the information that I need to find. 171 pages, where's that going to go then, Marshall? On the top or on the bottom? If it's 171 pages. Top, right? Because we want pages to map up with pages. So 171 pages, and then X minutes. That's what's missing. That's going to go on the bottom. Okay? It's a good question to ask. So then we're going to go ahead and do our cross product. We're going to do 62 times 171. That gives us 10,602. And then we'll do 93 times the X. That's going to give us 93X. And we set them equal to each other and then divide to solve. And we'll get that X is equal to 114, and that's minutes. Okay, any questions so far?
Oh, man.
All right, so that is dealing with simple proportions. We also have a very specific kind of proportion that we call the percent proportion. So that means that we have a percentage that's involved with the problem. So here's what our percent proportion looks like. It's called is over of equals percent over 100. Is over of equals a percent over 100. The is value in a word problem is known as the part of your problem. So that's very important for you to understand. Is going to relate to the part of your problem. The word of is going to represent the whole of your problem. And then, of course, a percentage is just a percentage. And this is going to stay constant. It's always going to be a percent over 100. That will never change. That'll always stay constant. Percent always goes over 100. Because a percent, like we talked about yesterday, a percent is out of 100. So we always put percent over 100. So with these kinds of problems, we're now having to identify which value represents our is or our part, which value represents our of or our whole, and which value represents a percentage. It's easy to identify a percentage because it's going to have the percent sign, right? If it has a percent sign, that makes it a percent. So in this very first problem, we have 50 is 20% of what number? Right off the bat, I can identify that the 20 is my percentage. So when I want to label what my parts are, I'm going to put my percent is 20. Now I still need to figure out what my other ones are. I need to figure out what the is value is going to be and what the of value is going to be. And I need to use those terminologies. It says 50 is. There's my is. 50 is connected with the word is. That's my is value. It says of what number. Well, we don't know what that number is, so what do we put when we don't know a number? A variable, or x. Of what number is the portion that's missing. So now that we've identified what the value for is going to be, of, and the percent, we can put it into our percent proportion and then solve. So it's always going to be is over the of equals percent over 100. So now that you've set up your proportion, you can do that cross product. We multiply our 50 times 100, and that gives us 5,000. We multiply x times 20, and that gives us 20x. And then we would divide. I'm going to go ahead and divide in pink because I know that my whole is what's missing. And so I'll find out that the whole is 250. So 50 is 20% of 250. Let's do one more together. This one says, what percent of 20 is 4? What percent of 20 is 4? So I want to identify my is, my of, and my percent. Let's take a look at these two numbers. Do either of these numbers have a percent sign with it? No. So then what does it mean that's missing? The percent. My percent is the value that's going to be missing. So when I set up my proportion, I know that that percent over 100 is going to be an x over 100. So now I've got to identify which one of these values is my is and which one of the values is my of. So it says what percent of 20 is 4? 20 is going to be an is or an of? Of. It says of 20 is 4. Okay, so now we can set up our proportion. Remember, it's always is over of equals percent over 100. 4 over 20 equals x over 100. Now we can do our cross product. We're going to multiply 4 times 100, and that'll give us 400. We're going to multiply 20 times the x, and that'll give us 20x. And then we can just divide. So we'll divide both sides by 20, and we'll get that x is equal to 20%. Go ahead and try number 3 and 4 on your own. Okay, let's go ahead and check and see how you guys did. So we have 60 is 25% of what number? So 60, what kind of value is 60? Is it an is, an of, or a percent? Isaiah? An is. Good. 60 is an is value. What about 25? Is that an of or a percent? Camille? Percent. Very good. So that means that our of is the value that's missing. That's going to be our x. So we're going to go ahead and set it up. Is over of, so 60 over x equals percent over 100, 25 over 100. And then we can do our cross product. We can multiply 60 times 100, and that's going to give us 6,000. Then we can multiply 25 times the x, and that's going to give us 25x. And then we're going to go ahead and divide. So we'll divide both sides by 25, and we'll get x is equal to 240. Okay, what about for problem number 4? We've got what number is 32% of 1,000? What number is 32% of 1,000? 32, is that an is, an of, or a percent, Natalia? Percent. Okay, that's a percent. Now I've had a lot of people go, but it says is 32. But it's got the percent sign, right? So we know that that's a percent sign. What number is, that's going to be the what? The variable. What number is going to be our variable. That means that the 1,000 is our of. 1,000 is going to be our of value. All right, when we set it up, we're going to have x over 1,000 equals 32 over 100. And then we do our cross product. We're going to do 1,000 times 32. That gives us 32,000. Then we're going to multiply x times 100, and that gives us 100x. And then we just divide. So we'll divide both sides by 100. Very good. And we'll get x is equal to 320. Okay, now, as always, it's not going to just be problems like these where it's what number is 10% of 15. It's not going to always be set up like that. Sometimes it's going to be set up as actual contextual problems, those physical word problems where we're dealing with like a real world scenario. So in those cases, that's when you have to utilize your understanding of a part in a problem and a whole in a problem. Remember, is will be our part, of would be our whole. So you're just transitioning to those concepts. Instead of is over of, we're thinking part over whole is percent over 100. So here, for problem number 5, the number of 7th graders in a school is 312. This is 39% of the student population. So how many students are in the school? So the only numbers that we have here are 312 and 39%. So that's really easy right here. There's our percentage. That makes that part simple. So now we just look at the 312. Does 312 represent a portion, a part, or does it represent a whole? So you have to think in context. The 312 represents the 7th graders, right? Is that a part or a whole of your school? A part, right? 7th grade is only a part of the school. So 7th grade being 312, that's the part of your school. That means the number of students, the total number of students, which is your whole, that's the value that's missing. And again, when we set these up, we set it up as part over whole, 312 over X is equal to your percent over 100, 39 over 100. And then, like always, cross product to solve. We do 312 times 100. That gives us 31,200. We then do X times 39. That gives us 39X. And we solve by dividing. So we'll divide both sides by 39. And we're going to get that X is equal to 800 total students. Why don't you guys try number 6 on your own? I know I usually do 2 examples with you, but why don't you try number 6 on your own? Because we might just skip number 7 and 8 to see if we can get on to try to get you to your assignment if we have some time. Huh? You already did them? Good.